In Unit 3, we're going to talk about descriptive statistic. However, we're going to extend the knowledge of descriptive statistics into this new domain, predictive analytics. And we're going to see a lot of overlap in those two domains, and we're going to see the extension, how predictive analytics has been extended from statistic and provided you with some methods, algorithms, and procedures to help you come up with predictions. So we start first with something that you are really familiar with, the mean. So if you want to describe any data set you have, usually you tend to look at the average of the items you have in your data. So this is what is called the center tendency. So we have three popular measures to describe the center of tendency of your data, which are mean, median, and mode. And we're going to talk about the differences between them and when we prefer to use one of them more than the others. Let's go back to Chris. So Chris is taking 5 classes, and each class has different class size. And we want to know, on average, what is the class size of the classes that Chris is taking. All you have to do is to calculate the mean, which its symbol is in mu. So you sum up all the class sizes and you divide them by the number of items you have here, 5, and you come up with a number that is the average of the class size. In our case here is 36. Now we were able to give the donation mu to that specific case because really those classes are the only classes he's taking. So his population consists of 5 classes. However, if you cannot have all your population and you have sample of your population, we use exactly the same technique. However, we donate that specific sample mean with X bar in that case. This is all what you have to change. So the X bar is a point estimate of the population mean. It's not the exact mean, it's an estimate. So let us go back to one of the examples we have, the car mileage case. So here, if you remember, we had this data about 50 cars mileages, and we want in that case now to calculate the mean. If we pick only the first 5, we are having an estimate for this car mileage, and that estimate can be calculated by summing the first 5 car mileages and divide them by 5. So the X bar in that case is a sample estimate. The mean estimate for the whole cars in being available this year. However, if you take all the 50, again, this is a sample estimate, the mean estimate, X bar. It is different than the one for 5 cars, but is more accurate. And we will never have the exact number because we don't have hold on all the cars generated this year or been designed and available for customers this year. We only have a sample, so always we have some type of sampling error in our estimates. Now the other central tendency measurement we can use what is called the median. And the median is very easy to be calculated. You just sort your items in your data, and if your items are odd number, you will pick the middle point. If it's even, you sum up the 2 numbers in the middle and divide them by 2. So that's the median. The mode is the most frequent item in your data. Sometimes you don't have a frequent item, so that means you don't have a mode. Sometimes you might have more than one, so you'll have more than two or three, maybe 2, so you have 2 modes, 2 peaks in that case. If you have more, maybe 3 peaks, 4 peaks. up to the type of data you are working with. Now, in general, when we look at the data, we consider the mean is the most accurate among those three measurements, or the most used. Let's put it in this way. I cannot say accurate, the most used. So let us open that data, and I would advise you, every time you see an example in your book, go ahead, download it from Blackboard and open it in Excel. So I went ahead and opened the car mileage case, the data set, and I'm using Excel, and from the tab titled Data, I'm gonna pick Data Analysis. If you don't see the data analysis in your Excel, just Google it, how to activate data analysis, or go back to the previous chapters that give you some details how to have the tab just available for you. It's there, but you just need to choose it as an option to be available. So I am going first to ask Excel to give me the descriptive statistics about the gas mileage data. And yes, what you have to do at the first point, you have to select the data that you want Excel to generate the descriptive statistic for. If you selected the first row as the label, in our case we did that, as you can see, mileage is our first item. In that case, we're gonna check the box that says labels in the first row, and then you just generate the values, and let us discuss what we see here in this table. As you can see, the mean and the median, the mean, median, and the mode values are very closely related. So I would assume most likely the histogram of this data is normally distributed. And if you are not sure about that, we can go back, click on the data analysis, and choose the histogram. And you have to pick the data. So let us select the data here from mileage to the last item. Yes, I have a label, so you make sure you selected this item. Let us produce the cumulative percentage and the chart. And here is our chart. As you can see, somehow it's normally distributed. You have the bell shape here. We're going to talk more in chapter 6 about more details about that. But in the time being, I can assume that this data is normally distributed. Okay, let's continue. And let us talk more about when you use, for example, median. One of the examples we have in Blackboard is the household incomes. So we have a 12 data sets points of incomes of people that they own a house. And if you look at the median of this data, since we have an even number, it's the sum of those two numbers, 41,000 and 49,000 something, divided by 2. So the median is, as we said before, it's a median point in the middle. Now assume the highest number here is not 190,000, it's 300,000. You will see that those 2 points that represent the median will never change. They will stay always the same. However, the mean is going to change because the mean will take under consideration every single point and divide it by 12, the number of items we have in this data set. So this is where you use the median. If you have a data that is skewed left or right, and you are worried that you have this data point at the edges that are really huge and that causes skewness into your data, the median is known for being more resistant to the extreme values, will not change, will always have the same value. However, the mean will go up and down based on one point that is extreme. So this is how you can distinguish when to use which. So I will advise you to open those exercises and to try them in Excel and to answer the questions of this chapter. And I will mention again that after the deadline of homeworks related to chapter 3, I will give you the solutions to all the exercises in your book from chapter 1 to 3, and you will be able to revisit those exercises, compare them with your notes, and have the right answers before you go to your midterm exam. Before introducing the measure of variation and why we need it, and this is will start with a new video, let me bring one of the examples we used actually in our chapter 2. So if you remember this case where a professor conducted 2 different exams and looked at the mean of each exam, we will, if you remember, we had a histogram that is similar to this graph over here, 2.12. This histogram shows you that we have 2 peaks in our data. We don't have a normal distribution. We don't have a skew to the left or to the right. We have a data in which has a distribution with 2 peaks. In that case, we cannot use the central tendency to give us a description of the data. Neither one of them would describe this data for us. That's why we're going to go to other type of measurements to help us understand this type of data. What else I should mention in your book? Specifically this area here in chapter 139. Now, when you have those 3 measurements very close to each other, as we saw in the car mileage, we say that this data is, because the data is symmetrically distributed, those values are almost the same. However, when you have a data that is skewed to the right, just remember it in this way, the mu always will be to the right of the median and the mode. However, if the data is skewed to the left, the mean will be on the left side of the mode, of the median and the mode. So this is an easy way you can remember it. In the next video, we're going to start with the variation, which is in your book, page 145.